I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, May 9th. Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype. Looking at significant wave heights for the South Pacific Ocean, we see a much improved pattern. There's a gale in the, we'll call it the northern central South Pacific with decent sized seas like 36, 37 feet. Another system developing southeast of New Zealand with 30 plus foot seas. Remnants of another system exited in the East Pacific, and it made rideable surf all radiating to the northeast, aimed mainly at California, but with some energy pushing to Hawaii too. So, it looks like summer is beginning to wake up again. As usual, we'll start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when they form, help direct their track. We're looking for a trough, that is, wind energy pushing to the north in the South Pacific. We have a good example of that right here. That is 130 knot winds pushing off to the north, then falling southeast into what they call a ridge when it pushes south. But in between there, that's the trough, and that area supports a clockwise circulation in the upper levels of the atmosphere and also down at the surface. And in the southern hemi, that's the signs of low pressure. And as we all know, low pressure, if it's strong enough, generates winds. Winds, if they're strong enough, generate seas. Seas, if they're high enough, radiate away from the fetch area and eventually turn into swell. And swell, when it hits your beach, turns into surf. So we have a trough in place here, generating, we think, some swell. And otherwise, not a whole lot to look at. Put this into motion as we get into Monday. Now another interesting thing happens. The trough kind of washes out in the far southeast Pacific, but wind energy starts building under New Zealand. Not so much a trough, but it kind of looks like it's trying to feed into that previous trough in the southeast Pacific. And then as we get into Tuesday, well, more wind energy starts building behind that at about 150, 160 knots. A little bit of a trough is to organize right here. We'll call it southeast of New Zealand. And then building some. It's more just a wall in front of this big ridge building under New Zealand. And that will support gale development as we get Wednesday. And then much more noticeable as we get into Thursday and Friday. And then building even more, maybe a little bit behind that. There you go. A broad trough over the extreme eastern edge of the Southern California swell window. And then as we get into Sunday, a week out, it pushes out of the swell window, no longer affecting California or Hawaii for that matter, and a broad ridge starts building over the entirety of the South Pacific. So things probably are going to go quiet about a week from now. Let's go take a look down at the surface and see what those charts tell us. Here we are, surface level pressure, surface level winds, remnants of a previous gale falling southeast, all fetch aimed south, doing nothing for us. But this new gale is organizing in the way up here at 40 south. That's pretty far to the north. Normally, most gales they call it the roaring 40s, but it's really more like down in the 50s and 60s where all the action is. When it gets up to 40, that significantly reduces the travel time to Hawaii or California. In this case, well, Hawaii is about 158, so this gale is east of there. But with 50 knot winds, maybe even a pixel or two of 55 knot winds in there, maybe some swell to be generated. And that new system, it actually looks like two systems here for the moment. That one's falling southeast, this one moving east with 50 knot winds. And as we get through, that was today, as a matter of fact. As we get into the evening, still 45 to 50 knot winds. This gale up here starts fading out. As we get into Monday, everything becomes focused on this one gale in the South Central Pacific, still looking solid with 40 plus knot winds, and then lifting northeast well into Tuesday, continuing more fetch building under New Zealand as we get into Wednesday, and then, but notice it was like northwest fetched aimed at Antarctica. But by Wednesday night, the fetch all turns off to the east, 40, almost 45 knots here, and then building into a new broad, I mean, look, there's a pretty good solid area of fetch here at 30, 35, 40, 45, well, almost 55 knots there again. Thursday, and continuing with secondary fetch behind this. This looks like oh, there we go, 50 knot winds as we get into Friday. Building, continuing over a giant fetch area Friday night into Saturday. I mean, this is actually an upgrade. And in the California swell window, not so much at Hawaii, and lifting north, we're still not at the end of the model run, but then as we get into Sunday, a week from now, everything fades out. Oops, and that's the end of it. So a pretty good, in fact, let's just do a quick run through this. You can just see 1, 2 systems, building, the third system. Quite a solid, long-running bit of fetch forecast. We would expect this would result in swell of equal measure. But before we even get there, we're not even going to look at this chart, but suffice it to say there is one swell already poised to hit California. Small swell, nothing huge, but something rideable. Another system then formed last Wednesday. We're going back half a week now. Under New Zealand, this is not a big system, 32, 34-foot seas. Later on Wednesday, sort of meandering across the Pacific, and then it faded. And then on Saturday, a new system. This is the one that was building way up far to the north, but on Saturday, small with 26, 27-foot seas. And then it was only today on Sunday morning, it started building with 38-foot seas. And, oh, here we go. And right to this moment in time with 37-foot seas with the new system building southeast of New Zealand. Looking forward, this system is to quickly die out, the one that's way to the north on Sunday night, but then the focus becomes in the south central Pacific, 38-foot seas, they kind of fade out, but then still a good broad area of 32, 34, 35.6-foot seas, lifting northeast on Tuesday. That system fades out. The next system pulls under New Zealand, just a broad area of 29 to 30-foot seas, but then that starts getting organized on Thursday and Friday in the southeast Pacific, again with seas building up to, we'll say, 37 feet and over a broad area. Now, this is the new part. This wasn't even on the charts this morning, so we would expect this probably to be more of a phantom than reality, but still, 39-foot seas building to 40 feet. From a very south angle relative to California, and then pushing out of the swell window and gone. So, all said and done, a pretty long run of surf looks possible. Just a quick look here. We've not shown this chart very often, but this is peak swell period. You just sort of get a sense of the lineup. Here's the swell poised to move into California. Now, you can't really tell it here, but the Tahitian swell shadows right here, it kind of cuts things off swell-wise. There's also wind swell and other stuff going on here, and that kind of masks out the actual swell that's going to be hitting, but it is there. It moves into California. You see it's hitting, but it's shadow. It's underneath piles of wind swell at the same time. Next swell pushing northeast behind that, it impacting the coast. Another system pushing through here's the Tahitian swell shadow. You can see it kind of just stomps it right off. That swell starts pushing north. Where are we here? I can't even see the time. Okay, we're at 150 hours. So we're into Sunday, and then that's the end of it. But you get it. 1, 2, 3, 4 swells lined up. Most of the focus, California, not so much Hawaii, but small sideband energy likely for the south shores of the Hawaiian Islands. And then the wind swell machine. The ridiculously resilient ridge, whatever you want to call it, La Niña induced high pressure, 1032 millibars, sitting right in the Gulf of Alaska. Not atypical for this time of year, but the persistence of it is pretty solid, much upwelling, cool to say the least, cold water temperatures along California, 30 knot winds, wind swell in effect on Sunday, trades 15 knots for the Hawaiian Islands, generating some wind swell on east-facing shores. Monday, more of the same, 30, we were actually up at 35 knots in a little area there near, we'll say Point Arena on Monday, and then fading some wind swell starting to back off for California later on Monday into Tuesday. Trades die off for Hawaii. Notice the high disappears for a little bit. Still, this persistent fetch is forecast to hold even into Wednesday, and Wednesday night off of Cape Mendocino before the next high pressure ridge starts building the Gulf of Alaska. Say Thursday night into Friday, not really getting good footing yet. Still 20-25 knot north winds. And then here comes the wind machine on Saturday. Again, 20-25 knot winds for all of California. East trades 15 knots for the Hawaiian Islands, generating wind swell. Then we get into Sunday, 35 knot north winds again. East trades, or east-northeast trades, 15 plus knots. La Niña continuing to take its revenge. Broad high pressure in control of the eastern half at least of the Pacific Ocean, and no immediate change forecast, probably not till we get into later June or July. All right, let's go take a look long term. What's going on with the Madden-Julian oscillation? And of course, La Niña. No sign of El Nino, at least not yet. As usual, we start by looking for signs of the active phase of the MJO. The MJO, the Madden-Julian oscillation, this periodic weather oscillation that travels west to east around the equator, around our planet. It has two states, an active phase and an inactive phase. When the active phase is on one side of the planet, the inactive phase is on the other side. They are not necessarily equal in strength at any point in time due to regional variations, these high and low pressure biases that can set up over parts of the planet that either constructively interfere. They call it constructive interference when you have La Niña, which is like high pressure, and the inactive phase of the MJO. When they get together, they're both like high pressure systems. They supercharge each other. Or when you have El Nino, which is a low pressure system, and the active phase of the MJO moves over that, then they are both low pressure systems. They constructively interfere with each other and basically amplify each other. Then the converse is true. When you have El Nino over the Pacific and the inactive phase of the MJO moving over it, well, El Nino is a low pressure. La Niña is a high pressure. When they intersect with each other, they kind of cancel each other out a little bit. The inactive phase of the MJO will stomp on the strength of El Nino for a little bit, and then vice versa with La Niña and the active phase of the MJO. Anyway, so we're looking for preferably the active phase of the MJO moving from west to east over the Pacific Ocean. This is the East Pacific here. This is the West Pacific here. This is the equator. This is the date line right here. This is data from the TAO buoy arrays, a series of buoys strung across the equator used for monitoring El Nino, but we can also use them to monitor the MJO. We're looking only at the arrows. The colors are water temperatures. Long arrows like this suggest strong easterly trades. And today they are over the East Pacific, the Central Pacific, and the all-important Kelvin wave generation area, the far West Pacific, 135 east right there. That's about as far west in the Pacific as you can go, to about 170 west, just over the date line, 5 degrees north and south of the equator. When you get the active phase over here and it's strong enough, it'll take the trade, stomp them out, maybe even reverse them. All right, we're looking for anomalies, the difference from normal for this time of year. Yeah, winds are pretty strong out of the east, but historically for this time of year, are they stronger or weaker than normal? Looking in the East Pacific, the arrows are out of the east, so it suggests they're a little bit stronger than normal. Same thing over the Central Pacific. And in the Kelvin wave generation area, maybe a little bit stronger more. So we'll say modestly stronger than normal. So that would tend to indicate no active phase of the MJO, instead the inactive phase of the MJO. Let's go look at the 1 week forecast. Here we go. So this is the whole planet on one chart. The date line runs right up the middle. So that's sort of the West Pacific. Actually 135 east is where it starts. So from the Pacific starts there. Kelvin wave generation area ends right about there. California is at 120 west. And Ecuador is about 80 west, right on there. You can sort of see there's like a line there. Okay, but it's the Kelvin wave generation area that we're interested in, right in there. Blues are east anomalies, the inactive phase of the MJO. So you can see up here, we had yellows, oranges, reds from 14th of April, traveling from west to east. That was the active phase of the MJO traversing the Pacific. Now the inactive phase is coming over, producing, we'll say, modest to moderate easterly anomalies. This is a 1-week forecast. Each tick marks 7 days. So for the next week, for the most part, you can see the inactive phase pushing through the Kelvin wave generation area, maybe starting to move out of it at the end of the week. But this is not a particularly strong easterly wind event, pretty much normal, about as strong as this active phase was a couple of weeks earlier. So let's look out 2 weeks now. And what do we have? Well, we have, so this is outgoing long wave radiation forecast going out 15 days, so about 2 weeks. But it's not winds. The yellows are, this is sunlight reflectivity off the ocean surface. So yellows and oranges on this chart mean more sunlight reflectivity than normal. Oh, and where are we? South America, Central America, right up there. Hawaii there, the Galapagos there. Equator, right through the middle of the chart. New Guinea, Australia, you get it. Kelvin wave generation area, right in here. The yellows, more sunlight reflectivity off the ocean surface. The inactive phase of the MJO. With the active phase, less sunlight reflectivity. Remember, the active phase of the MJO is effectively a low-pressure system. Low-pressure systems tend to generate clouds. Clouds don't let sunlight reflect off the ocean, and so that's how you get the blue shading. All right, so 5 days out, 10 days out, 15 days out. Well, it looks like the inactive phase is going to sit there, but get pretty weak and just slowly fade as the active phase tries to start moving into the West Pacific. This per the statistic model. Now, the dynamic model suggests pretty much the same thing, but at the very end of the chart, the West Pacific, the active phase of the MJO, makes a little bit better push into the West Pacific than what the that the statistic model suggests. So the dynamic model, a little bit more favorable to what we want to see, because the active phase went over the West Pacific, stomps on trade winds, reduces them. It allows warm water that's typically pulled up in the West Pacific to start sloshing east. And if the active phase is strong enough, it'll actually reverse trades and push that warm water east, not on the surface, but underneath the equator. And it will take about 3 months to move the whole way across the Pacific, eventually erupting off of Ecuador, creating a warm pool there. And if you have successive active phases of the MJO creating successive Kelvin waves, that's how you can kick off El Nino, assuming a host of other things also come into play. So that's why we always focus on this. Also, when the active phase is over the Kelvin wave generation area, it imparts energy to the jet stream, both north and south, and in like summertime, that can help feed the jet and help produce storms and give us southern hemi surf if everything lines up right. Let's drill a little bit deeper. So this is the statistic model here. This is the dynamic model, phase diagram charts. Basically, they map where the active phase is, where the heavy dot is, right there. This is like May 2nd, 3rd, 4th, 5th. You can, and then back into, April. You can go back to April 1st and see where how the active phase has moved from the maritime continent to the western Pacific, to the eastern Pacific, over the Atlantic, over North Africa, into the Indian Ocean a day ago, and today is, and the further the line or the dot is from this circle, the stronger the active phase was. So quite strong here when it was over North Africa, moving into the Indian Ocean, getting weaker, and these are 3 different projections from the statistic model of where the active phase will be 2 weeks from now, basically over the maritime continent, like Bali, and pretty weak. According to the dynamic model, it suggests the active phase is to be over like we saw in the other charts, moving from the maritime continent into the far west Pacific, and we'll say modestly strong. So a little bit different outcome from the 2 models, but again, going 2 weeks out, there's lots of room for error. We'll see as we get closer. Now here's the upper level model. 8 different panels. Each panel represents 5 days. It goes out 40 days. In each panel, there's South America, Peru there, the Galapagos, Central America, the equator, 0 degrees right there. Okay. New Guinea, Australia, the Philippines, so the date line's roughly right about there. We're looking at this is now not cloud cover, not wind direction, but precipitation potential in the upper levels of the atmosphere, the jet stream level. Oranges, not favorable for precipitation. Dry air, the inactive phase of the MJO. The greens, favorable for precipitation, the active phase of the MJO. And this runs about a week ahead what happens down at the surface. So a week from, so right now in the upper atmosphere, dry air over, we'll call South America, Central America, and the active phase starting to move into the West Pacific. In 5 days, the inactive phase is pretty much out of the Pacific, moving into the Atlantic. The active phase makes its trek across the Pacific through about, the end of May, and then a little bit of a pause, and then the inactive phase shows up again, we'll say early June, and makes its trip across the Pacific. Anywhere from 4 to 6 weeks to get from one side of the Pacific to the other. And now the CFS model. This goes out 1 month, all right? Same deal, whole planet one chart, date lines running right down the middle here. Kelvin wave generation area from 135 east, so roughly there to about there, okay? The dotted contour, well actually the solid contour here, was a previous active phase of the MJO. Good illustration of it, developing in the Indian Ocean, moving across the Pacific and into the Atlantic and then to Africa. Today, the reds and oranges are westerly anomalies. So this traverses the planet. Now, the inactive phase, well actually this was about April 24th, built in the Indian Ocean. It's making its way across the Pacific today and is supposed to be, for the most part, out of the Pacific, we'll say, or at least out of the Kelvin wave generation area in about a week. These are, each tick mark here is a week. 4 tick marks is a month. Okay? And then westerly anomalies starting to build within the next day or two, theoretically, in the West Pacific, but not quite making it to the date line. Notice sort of easterly anomalies sort of set up shop here, very weak. Stronger westerly anomalies in the west half of the Kelvin wave generation area. Weak easterly anomalies over the eastern half of the Kelvin wave generation area. And there's the active phase, the MJO, not even moving into the Kelvin wave generation area for the next month. And then let's go out a month beyond that. Now, the difference in this chart, this is a whole planet on one chart again, date line running right up the middle. Also notice when you look at this, that this is past performance down here. So strong easterly anomalies back in January. This was really the peak of La Niña. It's weakening easterly anomalies. Here's the current easterly anomalies making their way across the Pacific. Then you look up here and you see a light easterly wind pattern in the East Pacific, maybe building as we get into July. But where's the date line? Well, the date line's right there. And the western edge of the Kelvin wave generation area is roughly there. So for the most part, westerly anomalies from here on out, at least for a couple of 2.5 months, forecast in the Kelvin wave generation area. That's exactly what we want to see. In fact, let's overlay the MJO right now. There we go. All right, so today, dotted contour is the inactive phase of the MJO, traversing from the Indian Ocean, or actually this is over Africa, the whole way back to Africa starting, well, April 15th through about May 25th. That's a pretty quick circumnavigation there. Easterly anomalies today, right there in the Kelvin wave generation area, but forecast to not last very long. Westerly anomalies forecast developing in the West Kelvin wave generation area. The active phase of the MJO builds about the end of the month, pretty much takes over the whole way through mid-July with theoretically pretty strong westerly anomalies. So this would be a good target. Remember, the active phase feeds the jet stream, which feeds the storm track. So this suggests that in June and even as early as late May, pretty good sweet spot for storm production. Then we get into the July time frame, a little inactive phase of the MJO sets up, but doesn't do anything. With another active phase behind that, the real issue is this blob of stronger easterly anomalies real, or just the model doesn't quite know what's going on? Let's overlay the low pass filter. All right, so this sort of talks about this high and low pressure bias that we've been discussing for months now. This dotted contour is the effective La Niña signal, peaking back in January and February. Today it's on the wane from four contours down to just 2 right now, and that second contour is to fade, we'll say, when we get to June. And then the final contour moves way off to the east, out of the Kelvin wave generation area, isolated to the far east Pacific, as this solid contour, the low pressure bias, which has been in the Indian Ocean, starts making its way off to the east, pushing well into and filling the Kelvin wave generation area by about mid-July. Now, the interesting part is it shows it retrograding, and that's what's feeding this supposed building pool of easterly anomalies in July. The model has had, any model that you're looking at that goes 3 months out, you never can put a whole lot of credence in it, and certainly when you're trying to predict winds or anything significant. So this is all kind of voodoo at this point in time. We're not believing it, and you certainly can't start drilling into the details, but maybe, just maybe, there's a sense that, well, maybe we're not going to get this low pressure bias fully filling the Kelvin wave generation area as we get into fall, but it's way too early to know. We're still in the spring unpredictability barrier. That goes till the end of May. Once we get into June, I think we'll have a better idea of what's going to go on long term. But for the immediate future, for the next, well, May 9th to July 9th at least, westerly anomalies in control. That's exactly what we want. That's good for storm production. All right, enough MJO discussion. Let's go longer term, talking El Nino, La Niña. Clearly, we're in La Niña right now. We're trying to get out of it. Things are moving in the right direction. So first off, let's go see what's going on down in the ocean. Subsurface. This is the East Pacific here. This is the West Pacific here. These X's are sensors on the anchor lines of the TAO buoy array, that series of buoys strung across the Pacific used for monitoring El Nino. The key thing here is, so the reds are centigrade temperatures, 29 degrees centigrade, warm water building in the West Pacific. The 28-degree isotherm last week, which was, I think it was about 167 west, has now made it to almost 160 west. So it suggests warm water is on the move, pushing off to the east, indicative of a Kelvin wave in flight, at least. The 24-degree isotherm getting even thicker in the Pacific, again suggesting warm water pushing off to the east, again signaling the demise of La Niña. But these are actual temperatures. Let's go look at the anomalies, differences from normal for this time of year. Well, we clearly see plus 2-degree anomalies here. This would be like Ecuador over here. That's the surface of the ocean. You're going down. So Kelvin wave number 2 right here, with up to 3 degrees centigrade anomalies, and it is moving from west to east. Kelvin wave number 1, which is generated by a active phase of the MJO back in, was it February or March, poised to erupt off of Ecuador. So 2 Kelvin waves in flight, no sign of any cold water. If you remember last winter, this whole area from here to here was just packed full of cold water. That's all gone. Back to a normal, if not warmer than normal temperature regime, subsurface in the ocean. Another model using the same data suggesting the same thing. Kelvin wave number 1 just poised off of Ecuador. It isn't making any progress, or maybe there's something going on with the model here because it's showing warm water here and here, but it just can't ever seem to bridge the gap. Last lingering little bit of warm water off Peru, we think this is probably all gone. So this right here would be Kelvin wave number 1. Kelvin wave number 2, much bigger, building right behind it. All this entire river of water flowing 150 meters down the ocean. That's 450 feet down from the West Pacific to the East Pacific. Certainly no real cold water. Notice there is a little bit of cooling water here. But as this warm water reaches the surface and starts upwelling to the surface, it'll eventually get caught by the trades, fill all this in, and we should be in a warm regime, or at least a normal regime, we'll say a month or so from now. Another good sign, sea surface height anomalies. So what are we looking at here? There's South America. That would be Peru right there, Ecuador there, the Galapagos right there, Central America, Hawaii, those little dots right there. Of course, the equator there, the dateline there, New Guinea there. And what do we see? This is not water temperatures. This is the height of the ocean. Is it higher or lower than normal? If you strip out all the waves, all the wind waves, the tides, is the sphere of the earth from a water perspective where it should be, or a little bit higher, or a little bit less than normal? If it's less than normal, and we're only looking over the equator, then that means that there's probably cold water at depth. Cold water contracts, creates you a little divot on the ocean surface. If you have warm water at depth, it expands, creates a bump on the ocean surface. We're talking 0 to 5, maybe 10 centimeters. Well, that's not very much. And so the good news is, on the equator, we have positive anomalies the whole way from the far west Pacific into Ecuador as of today, other than this one little hole right here, suggesting that there is much warm water in flight pushing from west to east. Upper ocean heat anomalies. There's the West Pacific here, East Pacific here. Blue is cold, red is warm. Last year, when is this? In July, about the same time last year. Well, a little bit later, but one last little Kelvin wave tried to develop, didn't do much. Cold water was already locked over the East Pacific Ocean. It only built more as we got into September, October, November. Full-on La Niña signal, and now here we are in March. Warm water built, the trades died. Boom, one Kelvin wave. Here's the next Kelvin wave in flight. So 2 in a row. The question is, will this continue? Is there enough warm water over here to sustain this? Kind of looks like maybe not, like the warm pool is already tapping itself out. So it's kind of hard to tell right yet. But 2 Kelvin waves in flight, that will have some effect, at least in dampening, if not dislodging La Niña completely. The real big issue is what's going to happen as we get much later in the year. So let's go up to the ocean surface. What is going on? Well, all right, where's the equator? Right there. There's the Galapagos right there. Ecuador's there. Peru right here. Chile down there. Central America, Baja, Northern California, Southern California, Hawaiian Islands. Yellows suggest warmer than normal waters, so mildly warm, normal to warm temperatures down to the equator. A little bit of warming here off the Galapagos. And then this, what was a very pronounced cool pattern along Peru, which we believed was the Kelvin wave coming in, squeezing the last of cold water in the East Pacific up to the surface. That is all seems to be tapping itself out as of right now. And maybe the first little hints of the Kelvin wave starting to show at the surface. Hard to tell. The models all have a different handle on exactly what's going on. But this is real. This is satellite-based sea surface temperature anomalies. So there is some warming going on. But still, generally, I'd say, and it's only 5 degrees north and south of the equator that really matters. So 5 degrees north is somewhere like up here. Weakly warm, maybe a little bit stronger, cooler, but not by much. And the whole way out to the dateline. The sea surface temperature trend the past 7 days. Well, it certainly isn't getting colder off of Peru. I don't know that I'd say it's getting warmer. It's getting marginally warmer over an infinitesimal little area here around the Galapagos. Not enough to even be what I'd call statistically significant. And otherwise, about as neutral a pattern as you'd want to see. So not getting colder, but not getting warmer either. Just sort of dead for the moment. But we know there is a river of warm water streaming east right underneath all of this. And so we're expecting to see some signs of that somewhere around here. We almost thought we'd see it by this week, but maybe it'll be another week or two. And then the backed off view. You do see a sense of some warming right here in this view, but it's not very much. And generally a cooler pattern, but just barely cooler over the bulk of the equator. The official El Nino monitoring region, 120 west out to 170 west, 5 degrees north and south of the equator. So we've broken this up. Kelvin wave generation area here, official El Nino monitoring region here, and then the Nino 1.2 region right in here, kind of a noisy region because winds and local things can have huge effects on water temperatures here. But if you get a big Kelvin wave building, erupting, and temperatures really warm here, you'll see it. It'll be obvious. Sea surface temperature trend in the Nino 1.2 region, that area right by the Galapagos and Ecuador. Today, temperatures 0.556, 556 thousandths below normal, basically half a degree below normal. And they've been hanging that way since the end of March and not really going anywhere. No signs of Kelvin wave eruption yet. In the official Nino 3.4 region, the official El Nino monitoring region, the Nino 3.4 region, today temperatures down a little bit the past week, minus 0.090. So effectively neutral the past week. But you get the sense there's been a steady rise in temperatures since February. And that's what we want to see as you're coming out of La Niña. What does the atmosphere think is going on? We've talked subsurface ocean temperatures, we've talked surface temperatures, we've talked the MJO influence on all that, and now let's go look at the air column above the ocean. When the air column and the ocean are in sync with one another, when they're coupled, like they have been with La Niña, then this index tends to be very positive. This is the different Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Tahiti's over the Pacific. When low pressure is over the Pacific, the index goes negative. Today it's positive, 5.15, and it was up to 32.4 a couple days ago. Just sort of scanning this column, you see it's been, well, there's been some negative numbers, there's been some positive numbers. I don't know, let's sort of look at 30-day average, sort of sort it out. Today, plus 2.77, but it's been 0. It's been somewhere, it's still hovering basically around 0. It's not statistically significant. So neither El Nino nor La Niña for the minute. With the active phase of the MJO coming, with Kelvin waves in flight and water temperatures warming, we would expect at some point this start going maybe slightly negative. The 90-day average takes all the noise out of it. This is the El Nino La Niña indicator, 3.07. That's, again, statistically, effectively 0. We were up at 6.8. We were actually up at plus 15 at one point there. So neither El Nino nor La Niña. We can graph the 30-day SOI out to sort of see where we're at. Right here, about neutral. What's that, 3 or something like that? You can see back in 2019 we were borderline El Nino, down around minus 10. And then we got into 2020 and it's just been a steady upward rise from there. Other than this mega crash that has been going on since January, and now we're just sort of hovering. We want to see, so we're currently in the inactive phase of the MJO. We want to see this not rise a whole bunch. And then we want to see the next active phase of the MJO push this thing down a little bit below neutral. I mean, I'd love to see it way down here, but I don't think that's going to happen. But just somewhere down south of neutral to suggest that we really are in a neutral phase. That said, the atmosphere still thinks we're in La Niña. I mean, strong high pressure and control in the Gulf of Alaska, trade winds nuking, not so much for Hawaii, but certainly for California, northwest winds. Water temperatures way below normal locally. That said, everything else suggests all the underpinnings of La Niña are pretty much gone. So long term, where are we going? Well, the CFS version 2 model suggests, where are we? April or May, somewhere probably right around here. That's still forecast. The last good data we have is from, we'll say, the end of April. This is the middle of April here. So suggests water temperatures half a degree below normal, steadily rising to about minus a quarter of a degree in, we'll say, June, continuing through about August sometime. And then this model has consistently shown a fall back to a little bit more negative. This, as we get into fall and winter, half degree below normal, which isn't really La Niña, but isn't El Nino. We'll say it's neutral, bias negative. bunch of other models suggest no, return to full neutral. Way too early to know. We're in the spring unpredictability barrier. Got another 3 weeks or so to go. Even then, it's not going to magically sort itself out, but we'll see. I think this model is pretty firmly believing that we're not going to move to even a neutral state come the fall. And you saw the low pressure bias thing kind of moving, not getting well entrenched in the Kelvin wave generation area. All this from the CFS version 2 model. So we'll just have to play this out and keep our eyes on it over the summer. The immediate good news is there is small southern hemiswell getting ready to impact California. A second small one right behind that. The models suggest a week of I won't call it significant class, but solid fetch and a lot of consistent south-angled southern hemiswell is forecast per the models. This should set us up for a good long run of surf. Not aimed so much for Hawaii, though little remnants of it or sideband energy will get into Hawaii. But the main focus is going to be California down into Central America and into, we'll say, Peru, that area. Good, solid surf is possible, so we'll make the most of that. Beyond that, we're in the spring unpredictability barrier. We've talked it already. I'm not going to beat a dead horse, but we're not sure what the outcome is going to be. More than likely, a neutral pattern, biased, maybe weakly negative as we get into the fall and winter. Will that kill La Niña? We're hoping so. I think there's going to be a lot of talk about high pressure building in the eastern Gulf over the fall and maybe a delayed start of the rainy season for California as we get into the early part of the winter. But at some point that ridge is going to break down if La Niña doesn't redevelop, and if the low pressure bias does build pretty solidly over the date line and a little bit east of the date line, then hopefully we'll be in for a normal amount of precipitation getting into the winter. But that's almost a year out now. For right now, snow melting off quick in the mountains. We did a visual inspection over the weekend, and we can say there's still actually a pretty good amount of snow once you get above 8,000 feet. As long as you're not on east-facing slopes, west and north-facing. Still pretty good coverage, skiable, but Squaw is the only resort that's open, and even that, I think, they're going to get through next weekend and they're going to pull the plug. If you're hiking the JMT, something like that, still up high, 12,000 feet going over some of the big passes. It's probably pretty deep and pretty treacherous, but it is melting pretty quick, and the depths were not that high. I think we ended up with 30 or 40% of normal snow for the year. So use common sense if you're taking one of those routes. All right, if you enjoyed our video, give us a thumbs up. If you haven't subscribed, please subscribe. It helps the algorithms. It helps us. If you don't want to do any of that, that's okay too. Comments, always welcome on the video. If you have questions, just write them in and we will respond to them. And of course, if you don't want to do any of that, the link to the video, we do it Sunday nights for the most part, published at the top of every page of stormsurf.com. That's where most of the data that you saw tonight comes from. You can go there, you can watch the video, follow along, make your own predictions, and then check your knowledge with what we do in the video the following week. And if you have questions, of course, give us a comment. All right, thanks for watching. Go have fun, get some waves, and we'll see you next week. Same time, same channel.